Eric Darling here with Darling Data on an unexpectedly hot and sticky day here in New York. So unexpectedly hot and sticky that I think parts of my brain have just ceased functioning. It's just shut down. Like, nap time. We will siesta. We will siesta you tomorrow. That was bad. That was real bad. I should have thought about that before I said it out loud. I have that problem, though. I do have that problem. So today's video is going to be I've said in a number of videos about isolation levels. I like talking about them because exploring isolation levels is an important part of any SQL Server journey, because eventually you will hit strange concurrency phenomenons that you can't explain or reproduce or even find any real evidence of. And so I want to talk about what I've said in these videos is that almost no isolation level is universally perfect for every workload. And it's more about making a choice about how you want your application to behave under certain circumstances. So we're going to compare and contrast a little bit between read committed, the pessimistic isolation level, and read committed snapshot isolation, the optimistic isolation level. I know that I recorded a video sort of about this, but I came up with this demo that I like because it highlights a lot more of the weird changes that can take place while a query under read committed is unable to make progress, or even is just making slow progress for some reason. Like in the case that I'm using, there's some blocking involved. In real life, you might have a query that's just like has to read from a big table or like scan along or seek along a big index, and maybe that index isn't in memory, and maybe you have to maybe it take you a couple seconds, and a lot of stuff can change in a couple seconds. The point of this isn't like begin tran, do a few things, and like look at all the stuff that changed in like 10 seconds. It's like a lot of this stuff can change very quickly, like within like a few hundred milliseconds, and your query would still return just jacked up looking results. So I'm going to hit execute here to reload this table. I've got a table called read committed stinks. Perhaps a little overkill in the table name. I'm willing to give read committed a little bit of credit. I'm getting a haircut tomorrow, and this patch here is just annoying the crap out of me. But if I had the wherewithal, I would probably just shave my head at this point. Nothing but trouble. So this table has like some standard like account information stuff, ID and account ID, how much money you have in the account, your first name, your last name, when the account was created, and the last time you were active in your account. And I couldn't think of any good people names, so I just stuck a bunch of brunch menu items in the table. The prices do not reflect my respect for, adoration of, or preferences for these brunch items in any way. I just rattled them off the top of my head. So please don't try to infer anything about my brunch habits based on this table. And what I want to do is just give you a quick view of what this table currently looks like. It pretty much looks like what I did up there, except now it's a nice Excel format. All right, so that's all null. That's all like right now. We got first names, last names, values, everything that you could want in a table. Really, except maybe throw a nice XML or JSON column in there that just concatenates all that stuff together so that you can pull that out with your application instead. I don't know. People do dumb things all the time. So I want to make sure that read committed snapshot isolation is off for the first run through. And what I'm going to do is, I'm not going to do it quite yet. I'm going to have to hold on to those horses of yours for a couple seconds. So over in this window, I have a couple queries. This first query is doing a select from our knee-jerk table name, and the idea is to look for anything with an account value greater than or equal to 1,000. You could put, what's kind of funny about currency in SQL Server is you could put any currency symbol in front of that 1000 and it would find anything over 1000. SQL Server does not do currency conversion for you. So like if I made that like the pound sign or whatever the euro is, like it would just look for 1000. Like it wouldn't be like, oh, well, the pound is like worth an extra 50 cents or something. We're going to look for anything that's over 950. No, it just looks for anything over. So you can put any currency you want in there. You could put like, I don't know, whatever they use in Zimbabwe. If Zimbabwe is still a country, I'm not sure. You could put like 1,000 Zimbabwean dollars on there, and it would just be like, yeah, it's over 1,000, no problem. SQL Server does not do currency exchange rates for you. So you'd have to write a CLR function to go do a web call and check exchange rates and bring that back, and then do some local conversion. And I don't want to give you any worse ideas though. So this query looks for anything with an account value over 1,000. And if we think about what I put into the table up here, everything is over 1,000, right? Or 1,000 or greater, right? 1,000 through 10,000. And I've got this little decoder column because I'm going to make changes to the table that are not going to be reflected or might be extra reflected in the final results. And I have go to after this because I want the first go. So this is going to execute this one query twice. I want the first go to get blocked to show you what happens when a query gets blocked. Even for, again, like a couple hundred milliseconds, all this stuff could change in. And then run the query again afterwards. Because what I want you to see is that read committed, this pessimistic isolation level, is not a snapshot of your point-in-time snapshot of your data. And that running the same query twice in a row can get you very different results. And then I just have a query down at the end that just gives a select of everything in the table, right? So let's come back up here a little bit and let's switch tabs and let's go and begin a transaction. And what we're going to do is we're going to update the account value for ID 7, and we're going to leave that hanging for a second. Now again, just as I start this one off, again, like this isn't stuff that has to go on for a long time in order for you to get mangled results from read committed, the pessimistic isolation level, because all of these queries that I'm going to run to make changes to the table, like for instance, this is going to update 3 rows to set account value to 999. If you remember, our original query is looking for anything with an account value greater than or equal to 1,000. So these rows would no longer qualify. We're going to mess with a couple of primary key values, and I realize that primary keys don't often change in a database, but you might be working with other data that has more volatile keys. You might be working with data that does change fairly often, like the key of an index that does change fairly often, right? Certain relational values might change from time to time. And so you might see weird things where rows get thrown around and just juggled all over results. Think about like the context of Stack Overflow, where you might get a hot network question and your score might jump tremendously, very quickly. Or you might get downvoted into oblivion very quickly if you give a bad answer or ask a bad question or something. All this stuff can change, rapid fire. And you could move around in results, and queries results you should have been in that you're not, or query results that you shouldn't be in that you are. It's terrible, right? So I'm going to delete some rows, and then I'm going to reinsert a couple rows. Now, what I'm doing here is, again, kind of tricky. I'm just switching French toast and steak frites around, right? So they're going to both get values of 1,000, but I'm going to flip their primary key values and their user account values. I think, yeah, that's all flipping. So, yeah, made a bunch of changes, right? And again, I don't know how long I've been talking about this for, 10, 20, 30 interminable, uncalculatable numbers of seconds. But now I'm going to commit all those changes. All right? So, bloop, you go and do something. And now this query is finished. So what we got in our results, this first chunk of results up here, and if this SSMS would be so kind as to let me drag things around, the first set of results, remember we paused on ID 7. Right? ID 7 was where we paused because that's where we got blocked as we were setting the account value to 5,001. So we made a whole bunch of changes to this table that are either reflected because we moved things past 7, or not reflected because we made changes before the ID 7, right? So we read up to ID 7, got stuck, and we made a bunch of changes all around ID 7 that made these results weird. So like ID 9 didn't change. ID 11 used to be ID 6. ID 6 got set to ID 11. ID 7 was where we were blocked. This row got deleted. This value, and this value all got changed to 999. This got deleted and reinserted with different values. This got deleted and reinserted with different values. And now we have some weird stuff in the table. So coming back over here, right, and remember the table definition, where I not only have a primary key on ID, but I also have a unique constraint on account ID. And if we come over and look at the initial set of results, right, we have stuff that's kind of all over the place. We have 2 account IDs, 1006. We have 2 Scotch eggs in a row with different IDs, but the same account ID. We have 2 steak frites. Right? If we look here, where's that other? Whoa, that wasn't what I wanted to do. Yeah, we got stuff all over the place. Like here's, zoom back in there. Come on, zoom it, work with me. We got 1 steak frites here. We got another steak frites here. We got a bunch of rows with, account values that changed, right? Like these got set down, this one got set down. And this is the first run. This is just the block query, right? So a bunch of stuff changed around that query this read query was stuck. It did a bunch of reads and then went, oh, I don't know. I don't care if things change all around me. All I know is that I'm stuck here, right? We're just stuck on ID 7, and we made changes all around ID 7, and really the results should have looked like this. We should have only gotten 6 rows back, and we should have gotten 6 rows back with these values, right? Like this is the actual state of the table for accounts that have a value greater than or equal to 1,000 after all that stuff goes through, right? And this is just what the table looks like as a whole. So you can see, like, this is all just janky. Like, I think one of the things that like really sticks out is in the first result set, this last activity column, even though we made a bunch of changes and updated this for a bunch of rows, only 2 of the rows actually ended up with a last activity date, right? All the rest of them are null. So this looks bad and weird, okay? Like, it's not great. Like, if you think about like repeatable read or serializable, like sure, you wouldn't have necessarily those problems. You would just have fun deadlocking problems because, if you tried to, like, if you ran an update in the transaction and then selected data with serializable and then you ran another update, it would just deadlock, right? Just same with repeatable read. It'd just be over with, through, kaput, finito. So let's contrast that with, of course, RCSI. Now, I'm not saying that the RCSI results are necessarily better, because the RCSI results are, well, they're more consistent. I'll give it that, but you're still not getting back like the intermediate changes within all those things, right? So I think I have to rerun this because it's going to tell me that, oh no, it didn't work. Okay, good. All right, so let's reload the table. And for some reason something weird opened up on my monitor, so forget that. So let's reload the table, and now we have the table set back to its original state. We have RCSI turned on. And now if we do this and we look at the table, and we come over here and we run this, we're just getting a snapshot of the table back before this change to 5001, right? Because that first update that we run over here, we're saying set account value equals 5001, where ID equals 7. So we're still getting back the last known good row for ID 7, right? This did not change to 5001. We do not have a last activity date. And the same will go for all the other stuff that happens within this transaction, right? If we update these things, and we come back over here and we run these queries again, nothing in this table has changed, right? Like everything is exactly the same as before before things ended up being committed. And if we run this and do the inserts, and we run this, like we can still see that we're not reflecting any changes, right? We're not blocked, but we're still not showing the changes from within this transaction yet. if we commit this, of course, let's just make sure that's extra committed, and we run this. Now we see all the changes, but that was a lot like when, like in the second query, the first demo, when this query got blocked up and didn't show a bunch of wrong stuff, like inconsistent state data from the table, like as things changed around it, and then this one down here, which is essentially. Like from the first query, this one was essentially like the right results. Like we just had to run the query again after the blocking resolved, and this is sort of like the full state of the table. So, yeah, basically, coming back to my original point, no isolation level is exactly perfect. What you want to ask yourself when you're designing applications and when you're trying to choose things like isolation levels is what you would prefer. With read committed to pessimistic isolation level, if you remember that first set of queries that we did, we got blocked, and our query returned bad results anyway. So being blocked in SQL Server is not a pleasant user experience. It's not fun for anybody. So our query got blocked and then still gave us crappy results at the end. Under RCSI, we didn't get blocked. We didn't see all of the reflected changes just yet. We didn't get blocked though, right? Our query results returned immediately. I'm not saying that users would be maybe satisfied with that because they got back that snapshot of the table where ID7 still hadn't changed, right? We did all that stuff around ID7 and we didn't see any of those changes until the transaction committed. That might be right for you, but that might not be exactly what end users are expecting either. So really, it's just a matter of you asking yourself the question, do I want users to get, committed data back very quickly, or do I want to risk users getting blocked and getting crappy data back after getting blocked for a long time? For me, I would much rather prefer I don't think I need to rather prefer. I would say I would much rather, or I would much prefer, not much rather prefer. That's absurd. I should smack myself, self-flagellate for using English so dumbly. I would prefer that users get consistent data back until a transaction commits, and then see the final result of everything that happened in that transaction, rather than get blocked, get back some plumb weird results, and then have to rerun it again anyway. So you might not want that though. For some reason, you might hate your end users, and you might want them to get blocked, and you might want them to get janky results back, and have to run the query again. Maybe you charge them by the query. Maybe you charge them by the CPU tick. Maybe every month, at the beginning of every month, you record the number of CPU ticks, and at the end of the month, you record the number of CPU ticks, and whatever the difference is, you charge like $1 a tick, something. Right? Just a pretty good pricing model. I think. Wait, isn't that a DTU? That's interesting. Anyway, yeah. These are the application design questions that you should ask yourself. Now, again, something that I think obviously bears repeating, even though many of you, if you've been watching my videos, are already well aware of this. If we used no lock, everything would have been terrible. Right? We would have seen not good stuff along the way. So we're not no locking. We're not even gonna demo it because I don't want people to say, "Oh, look, Eric did no," like turn off the sound and just be like, "Oh, look, Eric did no lock in the demo and it didn't get blocked, and maybe that looks cool." I don't think that's all right either. So we're gonna not do that. What we're gonna do is take this time to reflect upon the applications we're developing and ask ourselves, what would we prefer users experience with our application? It might be okay for users to just hit refresh a few times and get eventually the right results, eventual consistency. Or you might just want them to sit there and get blocked for a while and then get weird results back. Start threatening to sue you or something. I don't know. I don't know how all that works. So take this time, take this lovely, well, I mean, it's Monday afternoon here. I don't know when you're going to be watching this. So take this moment now, this moment while you have it, Time is ticking and precious and fleeting, and you're never going to have this time back. So take this time to really think carefully about how you want your applications to function and how you want your end users to experience your applications. RCSI is usually a better choice for most applications and most application developers. It takes away a lot of the headaches that come with having to troubleshoot blocking and deadlocking between readers and writers, and it just generally gives you more consistent results without the concerns of no lock or read uncommitted. So, yeah, I think that's about good there. Like I said, it's hot and my brain is fried. So we're going to end this one here. Thank you for watching. I hope you enjoyed yourselves. I hope you learned something. I hope you all go turn RCSI on immediately. I kid, but I don't kid. If you like this video, there's a little thumbs uppy looky button, I'm told, on YouTube that you can say thank you with. Comments are another nice way to say thank you. And if you would like to see more videos like this immediately, hot off the presses, as soon as Bear Gut Magazine finishes cutting me my check and shooting me up with my adrenochrome, I can talk through this. Then I record the video. Then you can subscribe to the channel and experience me in almost real time. I guarantee you, I'm quite a real time experience. So you should do that. You and me. Subscribe-y buddies. All right. I'm going to go open Windows and take a cold shower. Maybe not in that order, but in some order. Eventually, that'll be consistent too. Anyway, thank you for watching.